Okay, so this is our last video. What we're going to do is talk about composite figures. Really, the whole idea of composite figures is they're just smaller figures like triangles, rectangles, and pentagons all joined together to make a larger one. The way that we solve these area problems is we just want to find the areas of each individual piece and then add those areas together to get our total area. So to start things off, I have a picture kind of like what you would see on a basketball court. Here's like the free throw line and the paint or whatever they call that. I have this rectangle that's 12 by 15, and let's say that I'm supposed to find the area of this thing. Well, I've got two areas to find. I've got the area of this rectangle, and then I have this semicircle attached to it. So first off, write out our formula for the first part. So area equals base times height. Okay, 12 times 15. Multiply that out, you should get 180 square feet. Okay, not too bad. Next part though, we need to figure out the area of this semicircle. And area equals pi r squared for circles. And if I have a semicircle, I'm going to divide that by 2. I just need to know what's the radius on that one. Well, if this is a rectangle, opposite sides are congruent, which means this diameter is 12, so the radius will be 6. So when I plug that in, that's going to be 36 pi divided by 2, which reduces to 18 pi square feet. And if I type all that into my calculator, so I'll say total area, that's going to be 180 plus 18 pi, which comes out to be approximately 236.5 if you plug that in. Square feet. Okay. Simple enough. Next one's going to be a little bit more challenging. I've got this trapezoid. It's isosceles because the legs are congruent. And it's attached to a regular hexagon. So first let's write the area formula for, say, for the trapezoid. So A equals half of base 1 plus base 2 times height. So I need the bases, okay, I've got those, and I need the height. I do not have that. So what I'm going to do is draw a perpendicular. If this is an isosceles trapezoid, this is going to be a rectangle in here. If this is an isosceles trapezoid, these two triangles are going to be the same, or they're congruent. So if that's 4, that's 4. And if I've used up 12 of this 16, I have 2 left over on each part. 2 plus 12 plus 2 is 16. If I'm looking for that height, I can use Pythagorean theorem. So h squared plus 2 squared equals 4 squared. 16 minus 4 is 12. Okay, so square root of 12, if we reduce that, it's going to be 2 square root 3. So area is half of 12 and 16 is 28 times 2 square root 3, and that reduces to 28 square root 3. Okay, that's square inches. Last thing we need is we're going to add this area to that regular hexagon. We just went over areas of regular polygons a little while ago. Write that to the side. A equals 1/2 perimeter times apothem. And so perimeter, that's 12, and I have 6 of them. Perimeter is going to be 6 times 12, which is 72. And then, as I've mentioned, the tricky part is to get the apothem. So let's go ahead and draw in our center, the apothem, and find some angles. So if you work out the angle formula, n minus 2 times 180 divided by n, you're going to see that each of these angles is 120 degrees. And that radius bisects it into a 60, oh look, 90, 60, 30. That's kind of nice. Now if this whole side was 12, that means this is 6. I don't really have to do a whole lot of work to find that apothem. The side opposite 60 is always going to be the side opposite 30 times the square root of 3. So apothem is going to be 6 square root 3. Alright, not too bad. So our area of our regular hexagon is 1/2 of 72 times 6 square root of 3. And let's see, that's the same as 36 times 6, so 180 and 36. I want to say that that's 216, but I'll just go ahead and multiply it out to make sure I don't mess something up. So yes, 216 square root of 3 inches squared. So that's for our regular hexagon. So the total area is going to be 216 square root 3 plus 28 square root 3, which is going to be, oh, you can just, square root 3. I don't know why I put a 2 on there. My bad. So 238, 244 square root 3 inches squared. And if you wanted to round off, you could type all that into our calculator. Times, let's see, square root 3. So I got about 422.6. Oh, sorry, can't see that. Okay, so that's how we work with composite figures. Divide and conquer. Area of smaller parts, add together, and that's it.